Alright, welcome to Closers Mathematics class. Don't forget to subscribe, like and share this video. In today's class, we are going to be talking about the mathematical induction and how do you solve questions under mathematical induction. Alright, so don't forget to subscribe, like and share this video. We are going to be looking at these two examples and I will explain it in details. Alright, so now let's come here first. When we talk about mathematical induction, what is mathematical induction? Mathematical induction is a statement. Mathematical induction is a technique used for proving. Are you following? Mathematical induction is a statement, is a technique used for proving a statement, theorem or formula that is asserted about every natural number. I hope you get my definition there. So for us to prove a mathematical induction, there are 3 steps involved. The first step, let's change our pen. The first step is that P of 1 is true for P of 1 is true. That's just the first one. P of 1 is true. That means when you do for n equals to 1, it is going to be what? True. I guess I'm saying when you do for n equals to 1, the statement is true. Then number 2 is that what? Is that P of k, or you can say n of k. I guess I'm saying P of k is true for some. So this one is true for some k belonging to the what? To the set of what? Natural number. Are you following now? Then the third one, which is the major one. This third one is the major one. Is that what? P of k plus 1. P of k plus 1 is true for all. Are you seeing that now? This one is true for all k belonging to the what? To the set of what? Natural number. So once you are able to prove these 3 things, then you will say that what? The formula is mathematically confirmed. I get what I'm saying, because that is what we want to do. So if you look at our first example, here, we have that we want to prove that 1 plus 2 plus 3 plus ... plus n is the same thing as 1 over 2 multiplied by n multiplied by what? N plus 1. You see, you don't need all these other things. I get what I'm saying. What you want to prove is this one. This is what you want to prove. I get what I'm saying now. So this is what I want to prove now. Are you following now? So let's prove that in the next place. So I want to prove that what? I want to prove that n, which is equal to what? 1 over 2 into what? Multiplied by n into n plus 1 is mathematically true. So the first step, so step 1. Are we following? So what will be our step 1 now? When n is equal to what? 1. So when n is equal to 1, what are we going to have? Anywhere I see n here, I will put 1, and I must get the same thing on the 2 sides. I get what I'm saying. So that will be what? 1 equal to, so instead of writing n now, I'm writing 1. Are you seeing that? So this is what? 1 over 2 into bracket. This n will become what now? 1. Then open bracket, what now? 1 plus 1 close bracket. This will now give us 1 equal to 1 times 1 1 plus 1 2. So this is 2 over 2, and that means 1 is equal to what? 1. Are you seeing that now? So since 1 is equal to 1 now, you will now say therefore it is true for n equal to 1. Are you seeing? So if you are in exam now and you see a question and you do for n equal to 1, you see, you can see it in your exam. When you do for n equal to 1 and they are not equal, I guess I'm saying, let's imagine that this place, now let's say I have let me change the color. Let's say I have let's say the question is n equal to 1 over 2 n into n plus 2. I see, you can see that this one I will have 1 equal to what? 1 over 2. This will be what? 1. This will be 1 plus what? 1 plus 2. And this will give us 1 equal to what? 3 over 2. So in this case now, you can see that 1 is not equal to 2. Then you say that what? It is not mathematically 2. Are you seeing that now? So but when n is equal to 1 like this place, then you say it is what? It is mathematically true. So it is true for n equal to 1. Are you following that now? So now we want to look at the next stage. What is the next stage? When n equal to what now? K. Are you seeing that now? So you want to do from when n is equal to k. So anywhere you see what's it called to, you will also put what? You will also put what's it called? K. So instead of writing n now, I will now put k. Anywhere I see n, I will put k. So that will now become what? K equal to, are you following? So that will become what? That will become k equal to 1 over 2. Instead of n, it will be what? K. Open bracket. Instead of n, it will be what? K plus 2. Are you seeing that now? So that is what I am going to have. I'm sorry, k plus 1, no, not 2, k plus 1. Are you seeing that now? It is still my formula that I am still using. I get what I'm saying? These are formula. I'm just changing my n to k now. Are you seeing? So you can see that n has become k there. N has become k. N has become k. So that is the only thing that we are what? That we are doing. Are you seeing that now? So for this one now, there is nothing you can do. I get what I'm saying? But you can go ahead and open the bracket by saying k is equal to what? 1 over 2. K times k will give us what? It will give us k squared plus what now? Plus k. Are you saying that k times k is k squared? K times 1 is k. I get what I'm saying? So that means this one is what? K equal to what? K squared plus what? Plus k all over what? All over 2. Let's call this one equation 1. Are you following? Let's call this one equation what? Equation 1. Are you following now? So now you are now coming back for the next. So for this one, you will assume that it is true. Are you get what I'm saying? For this one, when n equal to k, you assume. So they can ask you the question in CBT that when n equal to k, is it true? You are only assuming it is what? Assuming it is true. I get what I'm saying? You're only assuming that it is true for this one. So you leave this one as equation 1 like that. Then now when n equals to k plus 1. So now this is the last step. When n is equal to what? K plus 1. Yes, let me divide this like this so that I will finish it here. Now when n equal to k plus 1, that means anywhere I see n, I get what I'm saying? Anywhere I see n in our equation, in this our equation, I will now put what? K plus 1, abi. So now look at it. Just follow me. So that will now be what? K plus 1 equal to what? 1 over 2, abi. Instead of n, you know this is n. So instead of n, it will be what? It will be k plus 1 in bracket. Then now, you know this is n in our normal question. So that will be what? K plus 1 plus 1. You know 1 is in the equation itself. So this is n. I get what I'm saying? This is n, which is k plus 1. Then plus 1 that is there. So that will now be, this will now give us 1 over 2 into bracket k plus 1 k plus 2. Are you seeing that now? So this is what we are going to have. Now call this one equation 3. Are you seeing that? So what you want to now do now, I get what I'm saying? What you want to do is you are now going to come to equation 1. Equation 1, you are now going to say add. You are going to say add. This is how you do it for any mathematical induction. This is what you do. You now say add k plus 1. Add what? K plus 1. I get what I'm saying? You are adding k plus 1 to both sides of equation 1. Add k plus 1 to both sides. Add k plus 1 to both sides of equation 1. what's your equation 1? Equation 1 is what? K equal to what? K squared plus what? Plus K all over what? 2. So you now want to add K plus 1 to both sides. I get what I'm saying. You want to add K plus 1 to both sides. So this will be what now? This will be K plus what now? Into bracket K plus 1. Are you seeing that? Equal to what? K squared plus K over 2 plus what now? K plus 1. Are you seeing that now? So what you want to do is you want to now solve this part. Let's change this. You want to solve this particular part. If you can solve this part and you get this equation 3, then you are correct. Are you get what I'm saying? If you solve this right hand side and you get equation 3, then you are correct. So that will now give us what? So let's solve this part. What will be the LCM? The LCM will be what? 2. I get what I'm saying. This will be what? This will be K squared plus what? Plus K. Abi, then plus, this is over 1. So 2 will multiply this place. So 2 into bracket what? K plus 1. Are you seeing that now? This is like quadratic. Just factorize this part. Just factorize this part. That will give you what? K is common. What will you have? K plus 1. Are you seeing that now? Plus what? Plus 2 into K plus 1. You can see, remember the normal quadratic equation something. The two brackets must be the same thing. I get what I'm saying now. So since the two brackets are the same now, so I will have what? K plus 1, Abi. Then what now? K plus 2 all over what? All over 2. Now you can see that our equation, let's call this one equation star. You can see that this equation star is now equal to this equation 3. I see. This is the same thing. They are both the same thing because this one is also the same thing as what? As K plus 1, K plus 2 all over what? All over 2. Everything multiplied by 1 will give you the same thing. So since they are both equal now, you will say that what? It is true for all n equal to what? For all n belonging to natural number. Or you say it is true for all k belonging to the set of what? Natural number. Just like the way I concluded here. I get what I'm saying. Just like this my conclusion here that I wrote here. This particular third axiom. Are you seeing that now? That is what you are going to say, that it is true for all k belonging to what? N. I get what I'm saying now. Alright. So we have the example 2. Alright, so I will be solving the example 2 in my next video. Alright, so make sure you turn on the notification button so that you can see the video when I upload it. Don't forget the steps I did here. The first thing for you to do is to first do what? Is to first do for n equals to 1. After doing for n equals to 1, you do for what? For n. When you do for this n equals to 1, make sure the two sides are equal. If they are not equal like this, my example in this place, if they are not equal like this example, then that means they are not mathematically confirmed. I get what I'm saying. And for your CBT exam, if you are doing a CBT exam, once you do for n equals to 1 and they are not equal, you don't need to move further. All right, so after that, you do for n equals to k. When you do for n equal to k, whatever you get, you call it your equation 1. I get what I'm saying. And after calling that equation 1, you will add k plus 1 to both sides of your equation 1. When you do that, you are going to have what I have here. I get what I'm saying. So when you do for your k plus 1, whatever you get when you do for k plus 1 should be what you will get when you add your k plus 1 to your equation 1. All right, so I will do the next question. I will do the next question in my, this particular question, I will solve it in the next video. All right, don't forget to subscribe, like, and share this video so you can know when I upload this. Turn on the notification bell so you'll be notified once I upload the second video. Thank you very much for watching, and God bless you.